Good morning. Today let us see law of corresponding states. What is principle of corresponding states? How it is derived? How the equation is derived? What are its significances? Okay. First, if pressure, volume, temperature are expressed in critical constants, critical pressure, critical volume, critical temperature, then we obtain a new generalization called the principle of corresponding states. It was derived by van der Waals by substituting the reduced pressure in van der Waals gas equation. He introduced a new term called reduced pressure. What is called reduced pressure? It is equal to P by Pc, where P is the pressure of the system and Pc is the critical pressure. It is the ratio of pressure and critical pressure of the system. Okay, Vr equal to V by Pc. Similarly, Tr equal to reduced temperature equal to T by Tc. Okay, now on cross multiplying P equal to PR Pc and V equal to VR Vc, T equal to PR Tc, substitute these equations in van der Waals gas equation. P plus A by V square, V minus V equal to Rp. This is for 1 mole of a real gas. We have already derived. Please watch the lesson. Okay, now on substituting P equal to PRPC and divided by A by VR square Vc square into VR Vc minus V equal to R PRPC. Let us call this equation as number 4. Okay. We know we have already derived yesterday the critical constant Vc equal to 3b, Pc equal to A by 27b square, Tc equal to 8a by 27 Rb. Let us substitute these values of critical constants in the equation number 4. In the equation 4, then we get, for example, Pc equal to A by 27b square. Pc is equal to A by 27b square plus A by Vr square. Okay, Vr square and Vc equal to 3b, therefore 3b whole square 9b square, and similarly Vc equal to 3b minus b, and Tc equal to 8a by 27 Rb. Okay, now this is equation number 5. Now let us take out a by 27b square so that you will get Pr. So a by 27 square, let us take out. So you multiply the equation, multiply both the numerator and denominator by 3. 3a by 27b square. Therefore, a by 27b square will be taken out. Pr plus 3 by Vr square into. Let us take b out because b is common to both the term. Therefore, b is taken out. 3Vr minus 1 equal to 8Pr same. Okay. Now let us cancel. For example, B cancel. It will get cancelled. Right. Okay. Similarly, A. This side A is there. A can cancel. 27 is there. 27 is cancelled. And R cancel. Therefore, here you will get 8Tr. 8Tr. Similarly, here Pr. Okay. This term get cancelled and this P will be get cancelled. Therefore, Pr plus 3 by Vr square and 3Vr minus 1 equal to 8Tr. This equation is called principle of corresponding states or law of corresponding states. What are the significances of this equation? Okay, there are 3 significances. Let us see one by one. This equation, see, you compare this equation with the van der Waals gas equation. This equation does not involve R. This equation does not contain A and B. Okay, so this equation involves neither R nor A and B. A and B are called van der Waals constant. They are dependent on the nature of the gases. For example, carbon dioxide will have A and B gas, A and B values. and SO2, sulfur dioxide gas, will have different A and B values. Okay, van der Waals constant values. So this equation is applicable to all gaseous substances. Hence, because it is independent of this equation is independent of the nature of the gas. This equation is independent of the nature of the gas because it does not involve the van der Waals constant A and B. Okay, so it is this equation, this principle of corresponding states is applicable for all gaseous substances. Now let us define what are corresponding states. What are law of corresponding states? For example, let us consider two or more substances having the same reduced pressure, same reduced temperature. Then these systems, then they have the same reduced volume. Then they are said to be in corresponding states. They are in related states. Corresponding means related states. Okay. Then two or more substances having the same reduced pressure, reduced temperature, then they have same reduced volume. The two substances have the same reduced volume. Then they are said to be in the corresponding states. Okay. So problems may be asked based on this equation, and significances may be asked in competitive exam and also in your semester exam. Please study well. Thank you for watching.